Hey guys, welcome back to Perplexity, and today we're going to solve this amazing problem over here. So, what are we supposed to do here? You're supposed to find all the roots for the expression. So, let's start solving it. So, let's write down the question here. So, we have the cube root of 8 plus 24i divided by 3 minus I. So what we can do first is, on the numerator we can take out 8 common, and we can write this as 1 plus 3i divided by 3 minus I. Now obviously we know that 8 is basically the cube of 2, so we can surely take that out and we can write this as 2 into the cube root of 1 plus 3i divided by 3 minus I. Now what we can do is we can multiply the numerator and the denominator with 3 plus I, right? So what we're going to do is we have a 2 here, right? We will multiply the numerator and the denominator with 3 plus I. So what do we get? So we will get 2 into the cube root of, now let's open the bracket, so you will see 3 plus 9i plus I plus 3i square, right, divided by 3 square minus I square. So this is what we get, right? So let's continue solving this, right? So we go on this side and we can continue solving it over here. So what we have got till now is 2 into the cube root of, so let's add these expressions now. So we have 3 plus 9i, so we have 3 plus 10i now, right? 9i plus 1i is 10i, right? Plus 3i square, so I square becomes minus 1, so we can say that as minus 3 divided by 3 square minus I square, so that would work out to be 9 plus 1, right? So in this case 3 and 3 gets cancelled, we have 9 plus 1 and 10i on the top. So basically, technically speaking, what we have is 2 times the cube root of I. So this is where exactly the problem is, right? What the hell is the cube root of I, correct? That's what the difficulty is. Okay, there's a simple formula for this. Okay, we all know, right, that I is equal to e power I pi by 2, right? Now how do we know this? Well, based on Euler's formula, we can say that e power ix, so we know that e power ix would be equal to cos x plus I sin x, right? Now let's substitute pi by 2, so we can say e power I pi by 2 is equal to cos of pi by 2 plus I sin of pi by 2. Now this is very clear, right? Cos of pi by 2 is 0 plus I into 1, so naturally this works out to be I. So what we can do is, for the sake of solving this problem, we can say that, let's say z cube is equal to I is equal to e raised to pi by 2 plus 2 times pi n, the whole multiplied by I, right? Now what's the difference between this over here and this? It's the same thing, technically speaking. The only difference is that if you look at the Cartesian plane for the complex number system, right? This is I. Let's assume this is I, which is e power I pi by 2 as we saw previously, right? So when we add a 2 pi n over here, right, what we're doing is we're just going 360 degrees and coming back, right? So when n is equal to 1, it's 360. When n is equal to 2, it's 360. When n is equal to 3, it's 360. So basically this expression, there is nothing wrong with this expression. This expression is completely correct. Okay, so let's continue to resolve this. Right now, the thing is, you have to just remember this, that for the values of n to be 0, 1 and 2, that's where you'll get unique solutions. After that, the solutions are going to be repeated, right? So let's continue to solve this. So before we start solving this, what we're going to do is we're going to take the cube root here. So the cube root of z cube is nothing but the cube root of I, that's what we are supposed to find, is equal to e power pi by 6, right, plus 2 pi by 3 times n, the whole multiplied by I, right? Now let's substitute n is equal to 0. So when n is equal to 0, we can say that, so when n is equal to 0, we can say that the cube root of I works out to be e power pi by 6 I, which is nothing but cos of pi by 6 plus I sine pi by 6, which is nothing but root 3 by 2 plus I by 2, right? So this is the, obviously we still haven't completed, because remember the actual root for this answer is 2 times the cube root of I, right? So we are yet to multiply the value of 2, but we'll just park this over here, right? Now when n is equal to 1, right, we can say one of the cubes of I is going to be e power pi by 6 plus 2 pi by 3 the whole into I, which works out to be e power 5 by 6i. So if you multiply 2 here, this becomes 4 pi by 6, so 5 pi by 6, right? So 5 pi by 6 I, which obviously will be cos of 5 pi by 6 plus I sine 5 pi by 6, which works out to be minus root 3 by 2 plus I by 2. This is the, not exactly the second root technically speaking, but yes, obviously the second root for the cube root of I, right? Because we are still yet to multiply these roots with 2, right? And when n is equal to 2, the cube root of I works out to be e power pi by 6 plus 4 pi by 3 the whole into I, which works out to be e power, so when you multiply by 2, that becomes 8, so that becomes 9 pi by 6, which is nothing but e power 3 pi by 2, right? So this would work out to be cos of 3 pi by 2 plus I sine of 3 pi by 2. Now this would work out to be, so obviously this part becomes 0 and this is minus 1, so this is going to be minus I, right? So now we have found the 3 roots for cube root of I. So now to complete our answer, we found that the cube root of 8 plus 24i divided by 3 minus I was nothing but 2 into cube root of I, which is nothing but 2 times root 3 by 2 plus I by 2, comma 2 times minus root 3 by 2 plus I by 2, comma 2 times minus I. So the three roots are root 3 plus I, minus root 3 plus I, and minus 2I. So this is the answer to your question. I hope you like the explanation. Please like this video, comment on it if you have an easier way to complete this problem, and please share this video with your friends. Thank you so much. Goodbye.